Okay, last wee bit on this circle then. The last thing we're going to look at is a tangent kite. Now if we have a circle and we have any point outside the circle, we can draw two tangents to join to that point. And these two tangents, if we join them on with the radius in the circle, will make a kite. Now the good news is that line O to Q must be a line of symmetry. So those two tangents must be the same length. And we can use properties of a kite and a triangle, because we can cut it in half, to work out different angles. Okay, so whenever we get a tangent kite like this, because we have a radius meeting a tangent, these sides, move this down too far, must always be right angles. Okay, so it's just still a tangent meeting a radius. It's no different there. It just makes that kite shape, which means it extends it out and we can find extra angles. So looking at this one here, we're going to find these missing angles. Not sure what letter this says, I think it's a K. But that angle there and that angle there, which is K and N, must both be 90 degrees. Okay, if they're 90 degrees, we've got line of symmetry here, so N must be also 65 degrees. These two must also be the same. They look like, say, A and B, who knows? Don't suppose it really matters. Those two angles are both the same as well. We've got one at 90, 165, add them together. 155, take away from 180. Which gives us 25 degrees. Real trouble with my subtracting tonight. So A and B are both the same and they must both be 25 degrees. Okay. Second example then, a bit more of an exam type question you might get on this. So we've got a pool trophy. It's the shape of a circular disc with two pool cues as tangents. The radius of the circle is 6 centimetres. The length of the tangent to the point where it meets, so this line here, AB, is 9. The base of the trophy, arrows jumped a wee bit, so it should be from there to there, is 3 centimetres. And we want to calculate the total height of the trophy. That means we want to calculate the distance from the bottom of here all the way to the top of here. Okay, so we know part of that, well, we know quite a lot of it actually. We know that this part from here to here is a radius, so we know that this part is 6 centimetres. We also know that this part here is a radius, so that would also be 6 centimetres. That's not overly helpful. We also know that this part here is 3 centimetres. So we've got that of 3, we've got that of 6. I also know that bit's 6, but I don't know this part, but I want to find that all out in one go rather than two separate ones, because I can see a nice right angled triangle here. If I draw a line down from there to there, that gives me that full length. That's the bit I'm missing. That there is a radius meeting a tangent, so that is a right angle, and that right angle is pointing to that length there, so that's my longest side. I know the other two sides of the triangle. This one's 6, this one's 9, so I can find the length of this side here, which I'm going to call x. So x squared, it's my longest side, so I'm squaring and adding. So 9 squared plus 6 squared. So 81 plus 36, which is 117. That gives me x squared, let's square root it. Square root of 117 is 10.82. And then we need to remember and answer the question. So I wasn't asked just to find the length of the longest line here, I was asked to find the full height. So to find the full height, I take my 6, add on my 10.82, add on the 3 for the base, and I get 19.82 centimetres. And that is the end of the circle.